Alright, let's look at the homework 5.2, 5.3, problem number 14. Alright, so again, this is the water ski problem. Alright, and part A says that the profit on trick ski is $30 and the profit on slalom ski is $50. Alright, so we can come up with the profit function. So let's write that down first. So since it's a profit, we would want to maximize and profit P. Right, then I think it was $30 on trick skis, and X is the number of trick skis. And what was it, $50? $50. So $50 on slalom skis. Right, then this is going to be subject to the following condition. Right, so first one is we have to look at the fabricating hours. Right, total fabricating hour for trick ski would be 10x, so 10 comes from here. And total hour for slalom ski would be 8 times y, so 8y. So that's limited to 360, right? So we have a 10x plus 8y is going to be limited to less than equal to 360, right? Because that's the maximum number of hours for fabrication. And for finishing, again, it's a 1 hour per trick ski and 1 hour per slalom ski. So we have x plus y. So that's the total combined finishing hours. And this is limited to 40 hours maximum, right? And also we would have non-negative constraints, so x and y both greater than equal to 0. All right, so this is the linear programming for this problem. All right, let's try to solve this using GeoGebra. So I'm going to bring up a GeoGebra here. All right, so first I'm going to try to draw this region. All right, so you have 10x plus 8y is less than equal to 360. So we have a 10x plus 8y is less than equal to 360. All right, then hit enter. All right, we probably have to zoom out a bit. Let's see, zoom out a bit so that we can see the whole thing. All right, maybe here. All right, now we can see that. So maybe I'll move this a little bit so that so move this here. All right, so this is just the first inequality. All right, the second inequality is x plus y is less than equal to 40. So x plus y is less than or equal to 40, and then hit enter. All right, so you can see the region there. All right, so I'm gonna do that. All right, then we have a non-negative constraint, so we're gonna put x has to be greater than equal to 0. So type that in. Y is greater than equal to 0. Type that in. So we have that. All right. Then what we want to do is we want to use this feasible region. So the darkest region right here, right? That's the solution region. Right. Then what we want to do is to draw this profit function and try to make it as big as possible. Right? So I'm gonna put first 30x plus 50 is equal to p. Right? Hit enter. All right, so we want to create a slider for p, so I'm gonna click slider. Right? Then actually I need to change this. Right, so I need to change this slider, so I'm gonna say object property, and hopefully, all right, so this is a slider. All right, so I don't think profit is gonna be negative, so I'm gonna just start from 0. And the profit, let's see, it could be potentially be pretty big, so I'm gonna just just in case. So I'll just take put that will be 1,000 or something like that. Then increment could be 1, right? Then so that's probably let's see, that will probably work, right? So I'll do that, right? So this is the profit is 1. Then you cannot probably see it, but you can see if you move it. All right, so let's see. Oh, actually the equation is kind of messed up. All right, so here I have to change this to line 30. Yeah, I think I messed that up here. All right, I'm gonna change it. All right, I forgot to put the y there, so that's the problem. All right, so I'm gonna put y there, and then that should, yeah. All right, now we can see. So this is the profit function, and you can see that as you raise the profit, this profit function, the line for the profit function is actually goes up. Actually, P wasn't big enough, so I'm gonna do the right click and object property, and I guess I'm gonna put 10,000. Right, so here, right, then we can look at the, as the property goes up, right, you can see that the line's gonna go up, right. Then the farthest high up you can go would be somewhere on there, right. If you want, you can kind of zoom in to make sure that we're going through the last possible point there. See, so this black line is the profit function, right? And as you push the black line up to maximize the profit, and the last point in the solution region that the profit function profit line hits is this point. It's actually x equals 0 and y equals 40, right? So, and the profit there is 2,000, right? So let's try to see if we can put that in, right? So I'm gonna just close those two, right? It says this: maximum profit is 2,000, right? And the maximum occurs when you make 0 trick skis, but you're gonna make 40 slalom skis, right? This was actually kind of expected because you can see that the slalom ski gives you more profit than trick skis, right? And on top of that, slalom skis actually requires less time to fabricate it. So why not just make all slalom skis? So that's why 0 trick skis and you make all 40 slalom skis. All right, let's check the answer. All right, we got that. All right, then here it says discuss the effect on the production schedule and the maximum profit if the profit on the slalom ski is decreased to $35. Right, so you can see that the still, even though it's down to $35, it still gives you more profit than trick skis. So answer here, we know that it's going to be 0 trick skis and you're going to make 40 slalom skis, right? Then profit is going to be, of course, decreases too, right? So it's a 35 times 40, so it's 4 times 5 is, let's see, 20, and 4 times 3 is 12, so it's going to be 1,400. Right, so all I did was 35 times 40 because you make all 40 slalom skis. Right, so let's check the answer. Right, and we can also demonstrate that by using the GeoGebra too. So let's do that. So I'm still in part B. Right, so what we did was we changed this function. Right, so this is the profit function. It was 30, so 50 actually change it to 35, right? Then look at the difference, right? So you can see that here is the profit function, so you can see that, right? And as you move up the profit function, right, you actually still hit exactly the same last point as part A, right? So that's why it occurs at that 0,40, right? Of course, the profit will go down because a slalom ski doesn't make as much profit as before. All right, so makes sense. And part C, discuss the effect on the production schedule and the maximum profit if the profit on a slalom ski is increased to $60. All right, so we're actually going the other way, and the answer is actually we already know, right? Because you are actually giving you even more profit on slalom skis. And why bother making trick skis, right? So you're gonna have 40, and then so 60 times 40, so profit will of course increase too because you get more profit. And 60 times 4 as 40, so it's going to be 2,400. Right? So let's check the answer. Right? We got that. And actually, that's it for this problem. Right? So you never want to make trick skis in this case because slalom skis makes way too much profit. So why not just make all 40 slalom skis, and that would be the best you can do. All right, that's it. I hope that this was clear.